Hello, good morning. Today let us see last lecture of chapter 5, continuity and differentiability. Last time already told to all of you. Today we are going to see some multiple choice questions based on differentiation. How to answer that. See here. All of you are familiar with these things. See. Here it is very easy. That is equal to pi by 2, so derivative is 0. That we know. See. And see, this is the standard example, x raised to x. We know this answer is this one. Here they can change this one also. Sin inverse x plus sin inverse under root 1 minus x square. Condition is 0 less than x less than 1. 0 less than x less than 1. And that we know. Cos inverse x is equal to sin inverse under root 1 minus x square is equal to tan inverse under root 1 minus x square over x. Interrelation between inverse trigonometric functions. Okay. So that is equal to cos inverse x. So here we can write cos inverse x, and once again it comes out pi by 2. So its answer is 0. And we know that here, sec inverse something 1 over mod something under root something square minus 1 into d by dx of something, and that is nothing but x. But we want derivative at minus 3. So here minus 3, here minus 3 square. So 1 over 3 into root 8. So that is equal to 1 over 3 into 2 root 2. So it comes out 1 upon 6 root 2. Yes, it is very easy. Next one. See here. All of you are familiar that a raised to is constant term, so its answer is 0. E raised to some function, e raised to some function, d by dx of some function, that is 5, into d by dx of some function, that is dx by dx, that is 1. So this is the answer. We know that d by dx of log mod something or log something is equal to 1 by something d by dx of something. Here x is there. So this is the answer. 1 upon mod. 1 upon x. These are the simple answers. Later on we are going to see slightly tough example also. Now see. Once again, something raised to n. N time some function raised to n minus 1 into d by dx of some function. Some function is sec 10. So sec square some function d by dx of some function. That is what. So what is the answer? N 10 raised to n minus 1 sec square x. Is that anything? Yeah, here it is. Clear? Now it is given that this function is continuous, where order sign changes at 5 as well as at 10. So function is continuous at 5 as well as at 10. So function continuous at 5. So right hand limit is x greater than 5, that is 7 into 5, 35 minus 3, that is 30, is equal to left hand limit. What is left hand limit? Left hand limit x less than 5 then 5a plus b is equal to f of 5. And what is f of 5? F of 5 is also 30. So here we get one relation. 5a plus b is equal to 1. Directly we have to write it. At 10, right hand limit x greater than 10, then 10b plus 3a is equal to left hand limit x less than 10, then that is left hand limit is 70 minus 5, 65. So replace value of b here, 10b plus 3 of what is b? 30 minus 5a is equal to 65. Yes or no? Yes. Simplified. 10b minus 15b. Sorry, 10, here we are replacing value of b, sorry. 10b, what is 30 minus 5a plus 3a is equal to 65. So here we get 300 minus 50a plus 3a minus 47a is equal to 65. So 235, 300 minus 65 is equal to 47a. 7 5s are 35. So 47, this one is last to divisible by 47. So that comes out a is equal to 5. Divided, you can check it also. Take a is equal to 5. Here. So here 25. 30 is equal to 25 plus b, so b is equal to also 5. This one is the answer. Directly, without writing each and every step, we would answer directly. Now some function cube 3 times some function raised to n minus 1, 3 sin square x. And to derivative of sin x is sin some function cos some function d by dx of some function, that is d by dx of x, that is 1. So 3 sin square x into cos x. Here it is here. This is the answer. Okay? Next. See. This function is that we have to check it. See here. Fx is equal to x, 0 less than x less than 1, is a linear function, so it is continuous. And fx is equal to 1, x greater than or equal to 1 is constant function, so it is continuous. So for given range it is continuous. That means 0 to onwards, greater than 0, means positive real number. Is continuous at all positive real numbers. She is continuous at 1 only, that is wrong. F is continuous at x 1 only, that is also wrong. F is not defined at x is equal to 1, that is also wrong. Why? Because x is equal to 1, then it is 1. So it is continuous at on R plus. Next, see. Next amplitude. See, right hand limit, check it right hand limit. What is right hand limit? A minus a square by a, that is a minus a, that is 0. So this is not the case. This is also not the case because right hand limit is 0, so left hand limit, what is left hand limit? Left hand limit is also 0, see. Clear? Right hand limit is 0, left hand limit is 0, and x equal to a, it is also 0. So it is continuous at x is equal to a. Clear? Here, see, 1 by something minus 1 upon something square d by dx of something, that is minus 1 upon log mod x whole square, into log mod something 1 by something d by dx of something, that is 1. So what happens? Minus 1 upon x into log mod x whole square. Is there any answer? Yes, it is here. So this is the answer. Clear? Yeah. So in this way we can check it. And at that time, I also told to all of you, okay, whenever this infinity sums are appeared in the book, definitely they are going to ask for multiple choice question, not for written answer. So directly we have to answer some questions. Next. See here. Okay. Here 0 less than x less than pi, that is first and second quadrant. Why? Because then sign function is positive and x already positive, and we can take square root of positive quantity. This is why this condition is given to you. Now very easy, root something 1 by 2 root something into d by dx of something, that is product of x as it is, derivative of sin is cos as it is, sin as it is, and derivative of x is 1. Very simple. X cos x plus sin x over 2 under root x sin x. Is there any answer? Yes. Here it is. So this thing. Now for this one, some function raised to n. So 3 times some function square into d by dx of this one, that is 2x. Sin some function square, that is 2 times sin x into derivative of sin x is cos x into dx by dx, that is 1. So ultimately this comes out 3x square plus sin square x square whole square into 2x plus what is this one? It's nothing but sin 2x. Is there any answer? Yes. 3x square plus sin square x square whole square, yeah, into 2x sin 2x. Okay. Next, see. Y is equal to this one. Then y square plus y1 square. A sin x plus b cos x whole square, y square. y1 square derivative. A cos x minus b sin x. Yes or no? Yes. A constant as it is, sin something, cos something, d by dx of something. B as it is, cos of something minus sin of something, d by dx of something. Here middle term 2ab sin x cos x, middle term cancel. A square cos square x plus b square cos square x, so a square plus b square into cos square x. B square sin square x, a square sin square x, so a square plus b square into sin square x. And that comes out to 1. So what will be that? A square plus b square. Yes, is that anything? Yeah, here it is. So this is the answer. Next. Yeah, see. This type of sum we've already seen. This type of sum. Taking log on both sides. Log x is equal to what we get? A inverse y minus x square over x square. See, all options are in terms of x only. Means we have to make y as a head. Now taking n on both sides. So here n square inverse is goes outside. Next, take x square here. X square in log x is equal to y minus x square. So what is y? Y is nothing but x square tan of log x by g. So what is derivative? Here 2x. Here we can also take derivative of x square, that 2x 10 log x by g plus x square, that is 10 something x square something into d by dx or something, that is 1 by x, that is x cancel. So what we get? 2x, if I take it common, 1 plus 10 log x kg plus x square log x kg. Is there any option? Yes. 2x 10 of log x kg plus 1 plus, not x square, sorry. Not x square. Here x should be there. Or 2x 10 of 1 plus 1 log x sec. Only sec is there. Sec of log x kg. X square sec square x square 2x 10x into 1 plus log x kg. 2x 1 upon 10x x log kg. D is 0. Now see, option is there. Now, here it is, see, x square is given everywhere. So we did this one. So somewhere, see, print mistake is there. Here only x is there, and here x square is there. X square sec log x, sec is not only, it's not sec is there. We got 10 something. So sec square something. X square is 10 something. Sec square something. Yeah. Or we can, here only x is there because log x is 1 by x, that is x is equal to 1, so only we get x. So here some mistake is there, so you correct it. Now see, this answer, this case, 1 minus cos x, 2 sin square x by 2. 2 sin square x by 2, 2 cos square x by 2, that is 1 plus cos x, 10 square x by 2, all are in square root. So 10 square x by 2, so it comes out mod 10x by 2. Now see the range. What is the range for x by 2? Y by 2 less than x by 2 less than y, that is not in range of 10. Not range of 10. So multiply by minus x by 2 minus y by 2, add y, 0 less than y minus x by 2 less than y by 2. Yes sir. Now what is 10 of 5 minus x by 2? 10 of 5 minus x by 2, that comes out minus 10x by 2. So that is here, if I take minus and then we get plus 10x by 2. So 10 inverse is there. 10 inverse of minus 10 pi minus x by 2. So that comes out minus outside pi minus x by 2. That is x by 2. Y is equal to x by 2. So that comes out as what? Y is equal to x by 2. So divided by dx is nothing but 1 by 2. Same way, here also you can see that, see, here. Can you write here? 10 inverse 1 minus x over 1 plus 1 into x, yes, is nothing but 10 inverse 1 minus 10 inverse x. 10 inverse 1 is nothing but pi by 4 minus 10 inverse x. What is derivative of pi by 4? Is 0. Minus 1 upon 1 plus something square d by dx of something. So minus 1 upon plus x square is the answer. Let us see next one. See. Sine inverse 3 by pi into x 4 by pi into 1 minus x square. Consider x is equal to sine. Then root 1 minus x square comes out cos alpha. Clear? Let us consider this one as a cos beta is equal to 4 by pi. So, sorry, 3 by pi. So, what is 4 by pi? That is sin beta. So, what we get? Sin alpha into cos beta plus cos alpha into sin beta. So here we get sin of alpha plus beta. But the sine inverse of sin alpha plus beta is nothing but alpha plus beta. What is alpha? Sin inverse x. What is beta? Tan beta is 4 by 3. So tan inverse 4 by 3. So this is our y. What is derivative? Sin inverse something 1 upon under root 1 minus something square, and what tan inverse 4 by 3 is constant, so derivative. See? So what will be the answer? Answer is 1 upon under root 1 minus x square. You can see that thing. See? Yes, anyway. Here it is. So this is the answer. And here see one thing. We know that tan inverse x plus tan inverse y is equal to pi plus tan inverse x plus y upon 1 minus xy whenever x y greater than 1. So if I take this pi on left hand side, then it is minus pi plus. Now x is y is a. So what we get? Minus pi plus tan inverse x plus tan inverse a. That is our y. So what is derivative? 0, 0 here. 1 upon 1 plus x square. Is there any way? Yes. Here it is. So this is the answer. We also solved this example. If you remember it, that is the answer. We have to change the base in both the cases. Only solve. Next. See. See, first of all, let us see for this one. X less than 0. So what we get here? Minus x square. And what is its derivative? Minus 2. And is nothing but is x raised to x. d by dx of e raised to x log x. E raised to something into d by dx of x log x is e. And that is equal to c. Can I write here e raised to log x raised to x to the base e? X is the derivative of log is 1 by x. Log x is the derivative of x is 1. So it comes out x raised to x, and this is 1 plus log x. It's nothing but derivative of x raised to x is that. d by dx of x raised to x is equal to this thing. Okay? Yes. Now see. here. Parametric form is given. So it is dy by dx, dy by dt upon dx by dt. Denominator quantity whole square. Denominator quantity is it is. Derivative of numerator minus 1. Numerator is it is. Derivative of denominator quantity, that is 50. Same way here. Denominator quantity whole square. Denominator quantity is it is. Derivative of numerator is 2. Numerator is it is. Derivative of denominator quantity is 2. Now this get cancelled. So what we get here? Minus 2t common. So 1 plus t square minus, this minus sign is taken common. 1 minus t square. Here 2 plus 2t square minus 4t square. Sorry. Yes. So what we get here? Minus 4t over 2 minus 2t square minus 2t over 1 minus t square. Is there anywhere? Yes, here it is. So this is the answer. Yeah. So whenever parametric form is there, you can answer directly. Say, as far as multiple choices question is concerned, we have to minimize the steps to take the correct answer. But as far as written paper is concerned, then we have to write each and everything. Okay? That thing already seen. Next. See. Here, cot inverse is there. If I take x is equal to tan theta, then root 1 plus tan square theta. That is the root sec square theta. That is sec theta. Minus 1 upon tan theta. That is equal to, converting into sin cos theta, take LCM. So 1 upon cos theta minus 1 upon sin theta upon cos theta. If I take LCM, so 1 minus cos theta upon sin theta. What is 1 minus cos theta? 2 sin square theta by 2. Here 2 sin theta by 2 cos theta by 2. That comes out tan theta by 2. But that is equal to cot pi by 2 minus theta by 2. But cot inverse is there. So cot of cot inverse, that comes out pi by 2 minus theta by 2. Pi by 2 minus 1 by 2. What is theta? Tan inverse is. So derivative of pi by 2 is 0. Minus 1 by 2 as it is. What is derivative of tan inverse? 1 upon 1 plus x square into derivative of x is 1. Is that there? Minus 1 by 2 of this thing. No. Yes. Minus 1 upon 1 plus x square, minus 1 by 2 because theta by 2 is that. Okay. So here also some mistake is that there should be here minus sign. Then it comes out the answer. Minus 1 by 2 of this thing. Okay. Tan theta by 2. That is equal to tan inverse tan theta by 2. But whether it is in place that we don't know. But see, here theta by 2 is given to us. X belongs to r minus 0 except 0. But cot inverse of tan theta by 2, tan inverse of tan theta by 2. That comes out pi by 2. So there is no need to convert into this form. So there is no need to convert into this form. So what we get here? Cot inverse tan theta by 2 plus tan inverse tan theta by 2 is equal to pi by 2. is equal to pi by 2 minus tan inverse tan theta by 2. Of course, this is the answer. Yes, this is the answer. Next, here they want the second derivative. X is equal to 8 square. X is equal to 80 square and y is equal to 280. So what we get here, dx by dt 280 and dy by dt 280. What is dy by dx? dy by dt upon dx by dt. So 1 time. Now second derivative. So we have to differentiate with respect to x. dy by dx is equal to d by dx of 1 by t. So what we get here? D square y by dx minus 1 upon something square d by dt of something. So that is minus 1 by t square over dx by dt. So minus 1 upon t square over 280 dx by dt is 280. So what we get here, minus 1 upon 280 cube. Let me check, is there any option? Minus 1 upon 280 cube. Yes, this is the answer. Which one? This is the answer. Now derivative of this one with respect to n. But see, this is the not there. Differentiate this with respect to this. First one, let us call u. Tan inverse x upon 1 plus tan inverse x. And v is equal to tan inverse x. This type of sum we already see. Derivative of first function with respect to other function. So here we want du by dv. But put v is here. V over 1 plus c. So what is derivative of u with respect to v? Denominator quantity whole square. Denominator quantity is the derivative of numerator with respect to v is 1. Numerator is the derivative of denominator quantity is also 1. So we get 1 over 1 plus v whole square. What is v? 1 plus tan inverse x whole square. Is there any option? Yes, here is the option. This is the answer. Next. Here. Applying for this function, apply mean value theorem on 2, 4. The tangent at this one is parallel to the chord joining these 2 points. Here a f of a, b f of b. A f of a is nothing but a2. B f of b is nothing but b4 1. And here which theorem we want to apply? Mean value theorem. Recall the statement of mean value theorem. F of b minus f of a upon b minus a is equal to fsc. What is b in our case? 4. A in our case 2. What is f of 4? 1. And f of 2 also 1. Upon 2 is equal to fsc. Means fsc is equal to 0. What is fsc here? 2 times c minus 3 is equal to 0. So c minus 3 is equal to 0. Implies c is equal to 3. Fourth of go, applying mean value theorem on the tangent at point. So point is CF of C. C is 3. F of 3. F of 3 minus 3. Is there any way? Yes, it is here. Clear? Let us apply mean value theorem here also, then we are going to see middle one. For this part, A B, F of B minus F of A over B minus A is equal to F S C. What is F of 1? 1 minus 1. Minus 1 upon 1 minus 1 is equal to F S C. 3C square. So this comes out 1. So 3C square is equal to 1. So C square is equal to 1 by 3. So C is equal to plus or minus 1 upon root 3. That should be opening to minus 1 to 1. Yes, both values are in that one. So what is the answer? This is the answer for mean value. Now this one is the important for us. D square x upon dy square. We know that what is dx by dy? Minus 1 upon dy by dx. What we want d square x by dy square. That means we need to differentiate with respect to y. So differentiate with respect to y. And therefore d by dy of dx by d by dy of minus 1 upon dy by dx. So what we get here? D square x upon dy square is equal to 1 upon something. Minus sign is there. 1 upon something minus 1 upon something square d by dy of dy by dx. Clear? So that is equal to 1 upon dy by dx whole square. Here differentiation is with respect to h. So here we have to write d by dx of dy by dx into dx by d. Here it is differentiation with respect to x. So first of all we have to differentiate with respect to x, then x is with respect to 1. Okay? Yeah. So what is this one? Is nothing but second derivative d square y by dx square upon dy by dx whole square is there. And what is dx by dy? 1 upon dy by dx. So ultimately what we get? That is equal to minus d2y by dx square over dy by dx whole cube. Is the answer? Okay. Let us see. Is there any way? Yeah. Minus 1 upon dy by dx whole cube into d2y by dx square. This is the answer. Next. See. Apply Rolle's theory. F dash C is equal to 0. What is f dash x? E raised to x into cos x plus e raised to x into sin x. Why? Product rule. First function is the derivative, second one is cos x into d by dx of x, that is 1. Plus sin x is e raised to something, e raised to something. Okay. Now, this is the derivative. And therefore, f dash c is equal to 0 implies e raised to c, sin c plus cos c is equal to 0. Sin c plus cos c is equal to 0. E raised to c is not equal to 0. So So sin C plus cos C is equal to 0. We can write sin C is equal to minus cos C also. So tan C is equal to minus 1. So minus 10 pi by 4. Quadrant is given. C belongs to where? C belongs to open interval 0 to pi. First quadrant it is positive. So it should be in second quadrant. So C must be pi minus pi by 4. So that comes out 3 pi by 4. 1 minute. Here also Rolle's theorem we have to apply. What is F dash C? F dash X. Directly that we have to see. 3x square minus 4. So F dash C is equal to 0. 3c square minus 4 is equal to 0. So c square is equal to 4 by 3. C is equal to plus or minus 2 by root 3. But where is C? C is the open interval 0 to 2. So it is positive. So which value you have to consider? C is equal to 2 by 3. Is there any way? Yes, here it is there. Here. So in this way we can apply Rolle's theorem also. Let us see second one. Sorry, in previous one example is there. So but that is also in form of parametric form. X is equal to sec theta minus cos theta and y is equal to sec raised to n theta minus cos raised to n theta. Find out dy by dx and put the values and see x square plus 4, y square plus 4 or x square minus 4 or y square minus 4. That type of relation is there. So use any one of them. That is also easy. If you are not clear about that MCQ, also you can ask me. Now see, here. Let us see. Directly apply product rule. Derivative of x by 2 1 by a square minus a square as it is. X by 2 as it is. Derivative of root 1 upon 2 under root a square minus a square into derivative of a square is 0. Derivative of a square is minus 2. That. Root something 1 by 2, root something d by dx of something. That is minus 2x into dx by plus a square by 2 constant. Sine inverse something 1 upon under root 1 minus something square d by dx of x by 1 by a. Now a goes in numerator and it is positive, so a over a, that a cancel. So what we get here? 1 by 2 under root a square minus a square, that 2 cancel, this 2 cancel, minus x square upon 2 under root a square minus x square is there. Now what we get here? A square over 2 under root a square minus x square is there. So first one as it is 1 upon 2 under root a square minus x square plus 1 upon 2 under root a square minus x square common. Here what we get? A square minus x square. So one of that get cancelled. What we get? 1 upon 2 under root a square minus x square plus 1 upon 2 under root a square minus x square. If I take it common, 1 by 2, 1 by 2, that is 1, that is a square minus x square. Is there anywhere? Yes, it is here. So this is the answer. Next. Conditions of mean value theorem is not applicable to this interval. What is condition of mean value theorem? Function should be continuous on closed interval AB and it should be differentiable on open interval AB. These are the two conditions. Now see, is a polynomial function, so it is continuous as well as differentiable. Trigonometric function, continuous as well as differentiable. Continuous as well as differentiable. So only one remaining there. It is continuous, but it is not differentiable at x is equal to 0. We already proved f of x is equal to magnitude of x minus a is not differentiable at x is equal to a. So in that case, we can take x is equal to a is equal to 0 also. Yes. So this is the answer. Here, if I take x square is equal to cos 2 theta, x square is equal to cos 2 theta, then it will tell me 1 plus cos 2 theta, that is equal to, that is 2 root 2 cos squared theta. And same way, here we get 1 minus x square, that is 1 minus cos 2 theta, that is 2 root sin squared theta. Clear? So let me see. So if we divide by root 1 plus x over 1 minus x square upon 1 plus x square over 1 plus under root of 1 minus x square upon 1 plus x square. That is 2 root cos 2 sin theta comes out. So 1 minus under root 2 sin square theta upon 2 cos square theta, that comes out tan square theta 1 plus root tan square theta. So that is 1 minus tan theta upon 1 plus tan theta. Can I write here tan pi by 4 minus theta? Yes. Tan pi by 4 minus tan theta upon 1 plus tan pi by 4 tan theta. Tan pi by 4 is 1, so we can write that thing. What is outside? Outside tan inverse is that. So tan inverse of 10. So that comes out pi by 4 minus theta. That is pi by 4. Cos 2 theta is equal to x square. So 2 theta is equal to cos inverse x square. So that comes out 1 by 2 cos inverse x square. What is the derivative of pi by 4? 0 minus 1 by 2 is the derivative of cos something 1 upon under root 1 minus something square d by dx of something. That is 2. That total get cancelled plus x under root 1 minus x raised to 4. Is there anywhere? Let me see. Minus x over tan pi by 4 minus theta. So pi by 2 minus theta. Cos inverse, that is minus of minus. 1 by 2. 1 minus tan theta. 1 plus tan theta. Tan pi by 4 minus tan theta. Mod x less than 1. So nowhere it is answer given. Option is given minus x upon under. So here it is minus 1 to 1. So it comes out minus pi by 2 to pi by 2. So that is tan pi by 4 minus theta. 1 plus cos theta, 1 minus cos theta. So that is 1 upon under root. That is, this one is sin square theta, tan square theta, tan square theta. So 1 minus tan theta upon 1 plus tan theta. Tan pi by 4 minus theta. 1. See. Minus 1 less than x less than 1. 1 minute. Let us see boundary. So what is x? Cos 2 theta. Cos 0. See. Minus 1 less than x less than 1. Cos 2 theta. Here cos 0 and here cos pi. So pi greater than 2 theta So 0 less than theta less than pi by 2. So it comes in first quadrant. So minus pi by 2 less than minus theta less than 0. If I add pi by 2, then pi by 4. What we get? 1 minute. See. Then pi by 4 minus theta. So pi by 4, then what we get? We get pi by 4. Pi by 4 minus pi by 2, that is minus pi by 4 minus theta less than pi by 4. So it is range of 10, of course. So in range of 10. So here also some mistake is there. Then pi by 4 minus theta. So pi by 4 minus 1 half cosinus that thing. Cosinus is minus 1 upon root 1 minus x square. So here should be plus. Okay, here should be plus. Then this is the answer. Okay. Next one. See. Here also they want mean value theorem. See, but see, they are not asking, they are not putting anywhere that word. They are not putting anywhere that word. See, from the geometrical interpretation, you are seen in this way. See, in this way. So there is a one point on the curve with the line segment tangent at that point is parallel to line segment joining A and B. A and B. This is the mean value theorem. So A is equal to A1. B that is B E. So mean value theorem is f of B minus f of A over B minus A is equal to f dash C. What is f of B? E. What is f of 1? 0. Over E minus 1 is equal to f dash C. So what is f dash C? Now f of x is equal to x log x, y is equal to x log x. So what will be the f dash x? X over x plus log x. Why? X is the derivative of log x is 1 by x, and log x is derivative of x is 1. So directly we write f dash c is equal to 1 plus log c. So 1 plus log c base is equal to e over e minus 1. So log c base is equal to 1 minus, on this side. So that is e over e minus 1 minus 1. E minus 1 over e minus 1. So that is 1 over e minus 1. Okay, this is the value of c, log c. Log c is equal to C base E is equal to 1 upon E minus 1. So C is equal to E raised to 1 upon E minus 1. Is there any option? Yes. Here is the option. So this is the answer. Here see for this question. What they want? Apply mean value theorem for this function. And for this function, apply Rolle's theorem. What will be the C? For mean value theorem, for this one, for mean value theorem, f of 3 minus f of 1 over 3 minus 1 is equal to f dash c. What is f dash x? 1 minus 1 by x2. So what is f dash c? 1 minus 1 by c square. What is f of 3? 3 plus 1 by 3 minus 1 plus 1 by 1 upon 2. That comes out 10 by 3 minus 2 upon 2 is equal to 1 minus 1 upon c square. So what we get here? 6, 4 by 6. Yes, is equal to 1 minus 1 by c square. 1 upon c square is equal to 1 minus 4 by 6. That is 2 by 6. That is equal to 1 by 3. So c square is equal to 3. So c is equal to plus or minus root 3. But that should be in opening to 1 to 3 positive. So c is equal to root 3 in case of mean value theorem. In case of mean value theorem. Now here they want Rolle's theorem. For which one? For this function. What is f plus c is equal to 0? F plus c is equal to 0. What is f plus c? 2c minus 4 is equal to 0. 2x minus 4 plus 0. So what will be the c? C is equal to 2 and root 3. Root 3 and 2. Is that? Yeah, root 3. Okay? Yeah. On same line, if we apply mean value theorem to this function then, but interval is not mentioned here, so mistake is there for this part. So cancel this substitute because without interval it is not possible. Now here, see, if we apply mean value theorem to this part, see, in our case, what is f dash x? 3x square x less than 1. 3x greater than 1. Okay. According to mean value theorem, f of b, f of 2 minus f of 1 upon 2 minus 1 is equal to f dash c. What is f dash 2? Sorry. What is f of 2? Greater than 2 then 6 minus f of minus 1. Minus 1 less than 1, minus 1. 2 minus 1, 1 over 3 is equal to f dash c. This implies f dash c is equal to 5 by 3. But what is f dash x? We cannot write is equal to 3 because 3 is not equal to 5 by 3. So 3c square is equal to 5 by 3. So c square is equal to 5 by 9. So what can you say about c is equal to root 5 by 3? Is there any way? Yes. Here. So this is the answer. Dear friends, these are the multiple choice questions that thing already seen. Clear? So rest of multiple choice questions are given in that assignment also. You can refer any book also. Dear friends, this is the end of chapter number 5, including all sums. And see, to get good command over differentiation, please do that assignment thoroughly. Then there is no problem. And even though anyone of you have any problem, please contact me. You can post also me. On same day, I'm going to give the answer to all of you. Clear? And be prepared for next upcoming test for maths or also as well as for other subjects also. Clear? Thank you, dear friends. Next time we are going to meet with new chapter. Up to that, I think, how you